Dear participants, in this particular session, we are going to cover a very specific aspect of library automation. The aspect covers computer-based cataloging, GIST and Unicode standards, ASCII and ISCII. ASCII stands for American Standard Code for Information Interchange, and ISCII stands for Indian Standard Code for Information Interchange. But all of them are superseded, of course, by the present Unicode standards UTF-8, UTF-16 and so on. Library automation has undergone tremendous changes in last 2 decades. We have started our library automation just by converting our card catalogs to the online public access catalog, and later on it has been converted to web OPAC. OPAC stands for online public access catalog, whereas web OPAC is making it enabled in the web environment. This particular task of computer-based cataloging involves different languages. In this particular session, not only Indian languages, all over the world, several other languages also has to be taken into consideration for preparing their catalogs. Our intention is to understand the method of character recognition in computers, then learn the international standard codes such as ASCII, and then apprehend the need and the challenges in non-Latin character coding, and understand the Indian languages representation in computers. So the web content altogether, not only our catalogs or the bibliographic records, but the textual data also has undergone tremendous changes in last few years. Such contents and how to create the automation process in our libraries, how to apply computers, and whether the standard are following any international code or not, that has to be taken into consideration. And Indian characters, Indian scripts, how to handle them, because in India it's a plurality of languages, different languages, and all of them have a great chunk of knowledge in each individual languages. Sanskrit, of course, is very predominant, but Tamil and other languages are no less than their importance for the total knowledge domain of Indian languages. We have to learn different techniques and standards for handling different Indian languages in computers, and we have to understand the features of Unicode and how that could be applied in our library automation activities. Let's start our discussion from the historic background, where the representation of scripts of different languages in computer lacked a standard in representation. The present thought content in written form, one needs a script, and script is different from language. As we know, at present in India, we mostly depend on two different scripts. One is Brahmi, which was invented around 7th century BC, and Kharoshti during 5th century BC. This is about Indian languages, but other Mesopotamian civilization, Mesoamerica, China and elsewhere, they have also developed their script in a different way. Meanwhile, many scripts came into being like Grantha, Nagari or later Devanagari and so on. But the 5th and 7th century respectively, those scripts have not lasted long, and in due course of time many languages developed due to their migration of civilization, and accordingly different scripts in the Indian subcontinent were developed from Brahmi. So Brahmi were predominant. That is what our intention to say in this particular session. And representation of characters of a script in computer application is a complex process, and there are different standards for it. American Standard Code for Information Interchange is one such standard, and which has developed by a committee of software giants in 1962 and later on revised in 1967. But it could hardly address the problem of representing more than one script, because it has only 2 to the power 8, that is 256 character representations. 8-bit code, it is 1 byte only. ASCII is a 1 byte code for character representation, and that's why it only could represent 0 to 255, that is 256 characters, and that is extended from a stretch, but it uses only 7 bits. 8th bit is basically check bit or parity bit we call. On the lines of ASCII, other countries drafted their own code, and India is no exception. India has also developed, and that is developed by Bureau of Indian Standard. They developed ISCII, Indian Standard Code for Information Interchange, because Indian languages require different scripts and that cannot be accommodated within the ASCII. And what is the problems of character representation in computer? That within computers, each character is designated by a single number, because computer can only understand numbers, and that too only in the form of electrical current flow, that is switch on or off. But actual process is even more complex, as a computer is an electronic device and it only understands voltage. It cannot be considered that 1 volt, maybe less than little 1 is considered as on and off. And off is represented by 0 and on is represented by 1. This is how a particular system understands the notation of binary and that deciphers a particular character. That's why ultimately ASCII had tried to incorporate 128 characters, especially of Latin origin, and only Anglo-Saxon languages were taken care of there. And that's why in ASCII, a leveled key is pressed, then it is basically converted to decimal 65. If we want to check it, just type Alt 65, capital A will be printed on your screen. So Alt 65 basically indicates it is decimal 65, which is basically designed by ASCII to designate capital A, and that prints on the screen. Here we could say same way, character on B is also 66, C is 67 and so on. And their binary conversion again, A's conversion would 1 0 0 0 0 0 1 up to 8 bit. First one is 1 and last one is 1. Same way B, first one is 1, then 4 zeros, then again 1, then again 0 and so on. So this is how ASCII were taking care of. But Up to 63, there was to some extent IBM, AT&T and other types of computer systems were taking care of it, and one wants to write sorting programs or he or she can manage using ASCII value. But this particular version of code considered only the uppercase characters. Lowercase again were taken care of in 1967, and there again they have incorporated different diacritical marks, different symbols like curly brackets, pipe sign, tilde sign and so on. And those are again 0 to 9 were assigned from 48 to 57. Capital A to capital Z are from 65 to 90, and small letters small a to small z from 97 to 122 to get correct results when words or lines are sorted. But this extended ASCII, that is we considered Latin plus, they were taking from 128 to 256, accommodates non-Roman characters, non-Roman but Latin characters only. Non-standard character maps made it possible to use non-Roman characters with many standalone applications. And that's why in HTML hypertext markup language, a major issue arose by request for RFC 1866 has relied for character encoding on ISO 88591, that is Latin 1 version of it. Here are basically in ISO 8859 10 standardized character sets are there. One is for Latin 1 West European languages, Latin 2 East European languages, Latin 3 South European languages, Latin 4 North European languages, Latin Cyrillic, Latin Arabic, Latin Greek, Latin Hebrew, Latin 5 stands for Turkish and Latin 6 for Nordic. Compared to Unicode of the present day, these ISO 8859 character sets are extremely limited and they are usable only on the internet. But it stands for MIME software and they are a major improvement over the 7-bit US ASCII code. And that's why they had some significance at that time. But problems with ASCII is that only 128 characters it can accommodate, 128, and from 128 to 256 only 1 or 2 languages can be accommodated. Then it's a complete failure at that timing to handle all world languages. So definitely at that juncture Unicode seems to be a promising solution which covers all the world languages. Then if we consider our Indian scenario where different Indian standard code for information interchange were essential, because BIS standard IS 13194 has been developed in 1991. It's a 8-bit code again, and it is known as ISCII, Indian Standard Code for Information Interchange, and that is basically developed on Brahmi. It uses last 128 characters, that is from 129 to 255, that position for characters representation in Indic scripts. It uses the same keyboard as the ASCII with encryption on the 10 languages over it. So that was developed at CDAC, one institute at Pune. It's a government institute rather, for selection of ASCII and ISCII respectively. In ISCII, it is no doubt a solution for the Indian scenario, but when it comes to global representation, then we cannot find Russian, German or other languages, and we cannot exchange data with them. That is what the major problem. So ISCII and ASCII characters are placed in the lower half, that is 0 to 127 of the 8-bit code. while Indian script characters are in the upper half from 160 to 255. ISCII caters to the 10 Indian languages. Those 10 languages are Devanagari, Gujarati, Punjabi, Bengali, Assami, Oriya, Telugu, Tamil, Malayalam, Kannada. But other languages, as we know that Indian languages, even recognized Indian languages are many more. So to develop character sets for them was really a tough task at hand, and Bureau of Indian Standard were getting problem. They have developed the GIST card. GIST card stands for Graphics and Intelligence Based Scripting Technology, GIST, Graphics and Intelligence Based Scripting Technology, developed at CDAC again and supports major Indic languages. CDAC is located at Pune. GIST technology uses ASCII code for character representation using the extended ASCII tables, and GIST product uses underlying standards like ISCII, ISFOC, that is font for representation on screen, and thus we are getting for our earlier databases which are prepared using CDS, ISIS, computerized documentation system, integrated set of information services. There different hexadecimal codes were developed, and those codes were converted to O, A, E, this sort of Indian languages. Web applications of GIST also had happened because the software called iPlugin, it gives facility to develop the website in Indian languages, and those Indian languages again have undergone different changes in Unicode era, and we find now we usually replace it by Unicode, or even Windows 2000 onwards, when other languages, other Indic languages have developed. The biggest advantage with iPlugin is that now one need not download the language font on the local machine. Necessary plugins directly get loaded on the machine when website is accessed. So that is, when websites you are accessing, automatically that will come to your computer and you can get access to it. But constraints with ISCII also to be taken into consideration. It represents more than one Indian scripts in the same screen, as ISCII uses the same namespace. That's how 160 to 255 for all the Indic scripts. But as we know, India has several languages, so all of them cannot be accommodated within 160 to 255 uniquely. Each of them require some 8-bit character even to convert from English to any Indic languages. So if we have to convert from Bengali to English and again English to Tamil, we also require more than 128 characters for this purpose. So it requires a lot of labor from other languages to any Indic languages. That's why ISCII had tried a lot, but it was not possible to address the issue at that time. Now Unicode has been developed, and Unicode Consortium, which is a group of software organizations like IBM, Microsoft, Xerox, Oracle, etc. They came out of a 16-bit code and called it Unicode. It's a promise to cover all the world's scripts. The promising feature of Unicode is that it can represent 65,536 characters. That is 2 to the power 16. That is the capability of it. The first version of Unicode came in 1991. Since then, 2 more versions came in, and the present one is version 3.0. Unicode, which is identical with ISO 10646 BMP, is based on 16-bit encoding that permits 65,535 characters instead of the 256 characters. 256 means 2 to the power 8. So the Latin one, and in the 32-bit version of a capacity of say 2080, 000 and 000 characters, the BMP stands for Basic Multilingual Plain, and sometimes referred to as plain 0. While Latin 1 assigns a value of 1 to 256 to a character, Unicode assigns the value U plus NNNN, that is the number, 4-digit number to be put there. Unicode can be represented using 7-bit code also, 8-bit also, as well as 16-bit format standards. UTF-7, which is Universal Character Set Transformation Format 7, is a format that breaks the Unicode code point into 7-bit values, which can be transferred through email, which uses the 7-bit ASCII encoding, and on the internet. Whereas 8-bit sequences, which work well with web, UCS2, which Universal Character Set 2, stores each character as a 16-bit value, and each value corresponds directly to its value in the Unicode standard. So Unicode ultimately encodes text by script, not by languages, because we know languages are many more, but scripts, they may follow the same script. As we know, in Hindi, in Bhojpuri, in even other Marathi and Gujarati languages also, most of the cases Devanagari scripts are followed, and Sanskrit, Hindi, Nepali, all of them follow the Devanagari scripts. Character set standards relates to basic interchange of text. Unicode characters are made visible through a distinct rendering process that maps characters, entities used in data interchange that generically specify a particular symbol. To glyphs, we call glyphs, the particular shapes of a given characters as they are displayed. We call it glyphs, monotype imaging incorporated. So Unicode is a fully computable ASCII, and that's why the first 128 characters of ASCII characters are also taken care of, and any software using ASCII is compatible with Unicode. That is the advantage of Unicode, and Unicode has defined different language zones for their corresponding scripts. For example, Devanagari characters starts from 2304 and end with 2431. These many characters have been given, 2304 to 2431 Devanagari characters. It's a 16-bit code, and future extension also surrogate has been given. Unicode is concerned about characters, not about glyphs, and it renders logical ordering for writing from left to right, and in case of Hebrew, Urdu and some other languages, direction can be given from R to L or right to left. That is how in our HTML we can mention the direction, and we can prepare our web content with the help of that. Now let's come to the structure of Unicode. It's initially was the interest of software organization. That's why it became a boon for the software developing organization side by side, and popular also, and it supports multilingual communication, which ASCII fails at that time. It's fully compatible with ISO IEC 10646 set of standards developed by International Organization for Standardization, ISO, and International Electrotechnical Commission in 1993. UCS or Universal Multiple Octet Code, since the character code system uses 16-bit as well as 32-bit code, it is known as UCS2 and UCS4 respectively. What are the features of Unicode? It's known as Unicode, it's a 16-bit code, and it has to take care of existing ASCII coding system with respect to Indian scripts, and there are characters which use a combination of characters, like we have 2 or 3 characters together in different Bengali, Hindi languages. Such combination has to be managed with the help of Unicode, and 16-bit character code also. 16-bit character codes where 65,536 characters can be represented, and character positions, 2048 character positions are left for the future characters, which has not been utilized yet. In future, if those characters develops, that can be accommodated in 65,536. This region of Unicode is known as surrogate area, and surrogate area covers a large character positions. There are two types of surrogates: high level surrogates 55,296 and ends at 56,319, and totally 1024 character positions are there. 1024, as you know, that 2 to the power 10, and it starts from character position 55,320 and ends at 57,373. If we consider the efficiency of Unicode, it's no doubt that it's a very efficient code. All characters are not repeated here, and they can be simply borrowed from some other group of languages. And actually, Hindi characters are from 2304 to 2431, 2304 to 2431, and Bengali is from 2432 to 2559. Just after Hindi, Bengali is given, and Telugu is from 3072 to 3199, and so on. What is the advantage of it is for translating from one script to another script, we just have to add the value of it. So we have to make it plus or minus for just transliteration of one word to another word, transliteration, and that is what is used in Google to make the work done. So the characters and not glyphs, what is the advantage of it? In a sentence, the smallest unit is a character, which can be written and can have semantic value like O, A, E, E or A, B, C, D and so on. But glyphs are nothing but exposition of characters in graphical form. So how a character appears on display, that is known as glyphs. But glyphs may be bold, maybe italics or whatever. Glyphs are decided by the fonts, and the actual value of Unicode characters will remain the same. So you see A and the A in bold letter, A in italics, the Unicode value for all of them would be same. To display the different glyphs against each character is mapped, and it is necessary that a font must have a glyph in its source. That is why it is said that it is the property of font used for writing. Now, say for example, the plain text, when we say that ASCII 65, it is represented as A, capital A, which is a value in binary system, when earlier it was starting with 1, then in between all the zeros, that is all off, only first one is on and the last one is on. But here you see the first 8 digits has been given as zeros only, then it starts with 1, then 6 zeros, then again 1. So last 8 bits should be 1, then 6 zeros, then 1. Same thing, but it mapped to the Unicode. And the format added with the character, which is known as rich character format or TF format we call it. What is the logical order? Unicode stores characters in logical order, and that's why it is violated because of the representation of the text is reverse. Say for example Urdu, and in HTML we take care of it by providing another instruction, that is instruction is that order is right to left, so R to L. So direction dir is equal to within single inverted comma, if we put R to L, automatically it will be taken care of. Unification of Unicode, and it covers Chinese, Japanese, Korean character sets. Even hand script also is taken care of. Chinese scripts are many more in numbers, as you know. There are so many letters in the Chinese scripts. Compatibility characters are essential. For example, colon, character position 58, has 2 compatibility characters. that is 1 at character position 847, and ratio both are there. Colon may be used as ratio as well as colon, and other is at 1417. One is at 847, another is at 1417. You see, that is very important, because when we consider it as colon and when we would consider it as ratio. So American full stop also has same kind of practices, and that's why this dynamic composition is essential for Unicode character set map called its combining characters. And equivalent sequence also has to be taken care of for convertibility from one language to another languages. Now, web content development through the Unicode is also one of the very significant component of this particular session. As we know that while developing web pages in HTML languages, after Windows 2000 version of it, even from XP also, we had started by providing both in Devanagari as well as in the Unicode itself. Just a comparison, for example, if I want to put in central location position, then in Devanagari I put the name, say the name is Vidyasagar. So by Rasi Dai Jafala Akar Sa Dantya Sa Akar Ga Ra. Now same again could be implemented when we put ampersand hash, then 2351, 2352, 2366, 2350, 2359 and so on. And that should be within the body, and then only we will be able to visualize that in our web page. So both way we are benefited. We can put now our index script also as well as the Unicode. Unicode is a bit time consuming for our purpose. That's why we try to apply only our index scripts for this purpose. In libraries, this application of Unicode is very much significant. India is a country of diversity. Many languages are spoken here, and all the languages have a significant amount of literature. According to one survey, English is only language spoken less than 10% of the world population. Besides, India holds voluminous information in many of the native languages like Tamil, Telugu, Oriya, Bengali and so on. Libraries, particularly digital libraries, can record information in the languages and script of the source document. Even the bibliographic information can be represented in the languages also. So, all these computer-based scripts can again be machine readable, and machine readable cataloging, while Kuha or other software, they also should take care of these Indic languages. Features of computer-based cataloging, standardized record format, there also we have the application of all these ASCII, ISCII as well as the Unicode structure of it. And then what a comparison table is given here, where we find ASCII is a 7-bit code, ISCII is a 8-bit code, whereas Unicode is 8, 16 and 32-bit. Character count is 128 only in ASCII, in ISCII up to 256, and in Unicode almost 1 million. And language support, ASCII is English only, ISCII is Indian scripts, whereas Unicode is global languages. Current use is legacy only ASCII, and ISCII is very limited use, and Unicode widely used all over the world. What are the challenges and future prospects? Challenges: the language complexity, compatibility issues. Future prospects: improved multilingual support is essential, and for that we must have to address some of the issues which are Unicode will address in future. Like Chinese, It's an ideographic script which has more than 40,000 characters, but only 6,000 characters are in practice they utilize it. Rest of them like 34,000 characters are less used, very less used, rarely used. Japanese is a little different from Chinese, and thus politically they demanded the separate zone, which creates a political dilemma in Unicode. In 2001 onwards, we have been facing that, and Unicode is used in Windows operating system. There are developments in the Linux environment, but the problem of glyph still exists, like from converting to bold to italics or italics to underlined and so on. They have some problem yet, and Windows 9X, Windows Millennium Edition, XP Edition are shipped with USP 10.dll, which is also known as unscribe. But some of the features of the program do not function for representation of complex scripts. There are text editors developed in Linux that support Unicode, and UDIT is one such editor. UDIT, YUDIT, is one such editor which supports European languages also, and browsers alone cannot display multilingual text without the support of operating system. In machine which Windows 9X and ME, that can also accommodate all these things together. So at this juncture, we are really in a position to say that though our Unicode has given so much solution to us, but it has yet some problems which needs to be addressed for future aspects. Here we have enumerated some MCQs for you, like what is the main purpose of computer-based cataloging. First option is to store physical books securely, to manage and organize bibliographic records using software, to replace librarians in libraries, to support multimedia playback. Of course, to manage and organize bibliographic records using software. That is our basic purpose for computer-based cataloging. Which of the following is a feature of ASCII? Supports all global languages? Of course not. 8-bit encoding standard, that is also not. 7-bit, 8-bit, both are there. Represents English letters, digits and symbols. That is the features of ASCII. And it is not developed by CDAC India. CDAC India has developed ISCII, you know. And what is ISCII primarily designed for? Representing Indian scripts in computer systems, managing library books, encoding multimedia files, supporting global languages like Unicodes. Here representing Indian script is the main purpose of ISCII. And another two MCQs are there, which the organization developed the Unicode standard. Unicode standard is developed by Unicode Consortium, and CDAC developed ISCII. What is the main advantage of Unicode over ASCII? Main advantage is Unicode supports all major scripts and languages globally, and descriptive questions are there which explain the process and key features of computer-based cataloging. We must discuss the significance of ASCII in digital communication. What are the main characteristics and limitations? Describe ISCII and its role in supporting Indian languages. What is Unicode? How it can be implemented for designing web pages. And finally, the role of gist card in specific circumstances where ISCII were used to disseminate different Indian languages. These are the long range questions for you. Thank you for your kind attention.